So preparing for, again, we're rebranding this. We're not calling it the mini test. We are calling it the big quiz. All right, which means nothing has changed. All right, the force of two charges separated by a certain distance. What equation would we use for that? Anybody?
QQ over R squared.
Yeah, KQQ over R squared. How many charges do we need to find that force? We need 2. Okay. What about the force on a charge in a particular electric field? What equation will we use for that? Yeah. Sure, why not? Okay. So what equation is this? A force on a charge in a particular electric field, assuming we know what the charge is.
E times Q.
Okay, good. So force is equal to the electric field times the charge. Okay, that comes from the equation, the fact that the electric field is by definition the force per unit charge. Okay, what about the electric field a certain distance away from a charge? In other words, electric field away from a point charge. What's the equation for that?
Negative V over V.
No, that's for later. But you're right. So you're talking about electric field, 2 regions separated by a certain distance having a different electric potential. That's this one here. So number 7, electric field is negative delta V over delta D. Okay, so we covered that one. So what about 3? What's the electric field a certain distance away from a charge, a single point charge? Remember that?
Q over R.
K almost. KQ over R squared. Okay, so how many charges do we need to make that electric field, the one that corresponds to the equation in 3?
1.
We just need 1 charge, okay, 1 point charge. 4, the electric potential energy stored in a system of 2 charges separated by a certain distance. What equation will we use there? Good, the electrical potential energy, okay, or EPE is equal to the KQQ over R. All right. The electrical potential a certain distance from a charge. The electrical potential is V, so what's that equation? KQ over R. All right. The work it takes or the amount of energy released when a particle moves from one region of one potential to a region of another potential.
Q delta V.
Okay, so UE, which is equal to the electrical potential energy, is equal to Q delta V. Okay. And then let's list which are vectors and which are scalars. So which of our quantities there are vectors? In other words, the direction matters.
R.
Well, yeah, I mean, but of like the new topics, like the forces, electric fields, which are vectors and which are scalars? Okay, electric field is a vector. What about force? Is force a vector? Yes, force is a vector. Okay, these quantities, which are scalars? Okay, electric potential is a scalar. In other words, direction matters. I mean, direction doesn't matter, but it's still important to put the negative signs in. Okay? What about energy? Is energy a vector or a scalar? It's a scalar. Okay?